This is the second part of the tutorial about HeadRoom. In this part, I'm going to show you how to use HeadRoom in conjunction with Spark and use the HeadRoom node inside Spark. In part 1, I showed you how to use the HeadRoom application and configure it. And I'm going to start up Spark now. The operating system asks me if I allow incoming network information. I say yes. Obviously, I want to be able to receive the transformation data from the Spark application. I'm going to create a new project. I'm going to save it inside the tutorial examples. You will find in there already a 06 HeadRoom Spark project. And I'm just going to recreate it here for the purpose of this tutorial. First thing, I'm going to close down the edit window and resize the 3D viewer, and then I create the first node, which is a grid node. Switch it on, tell it to draw it to the main render group and change the update frequency. Actually, my machine shows significant problems of running all those applications, including the screen capturing at the same time. The next thing is I'm going to create a HeadRoom node, switch it on, and tell it to draw it to the 3D viewer. And we already see here all the data is being sent over from HeadRoom. It's using the same coloring for all those different features. And we basically can just start on patching inside Spark. So the first thing I'm going to create is another transformation node. I'm going to call it look at transform. And I tell it the parent should be the HeadRoom gaze point. Gaze point is the salmon colored dot here, hovering in space. And the next thing is I'm going to create a 3D camera, again 3D space. I'm going to create a look at camera, switch it on, tell it to draw it on stage. The parent should be HeadRoom eye, and it should look at the look at transform node. Inside properties, I'm going to tell it that it should be adapting. And I'm going to set the width and the height of the look at camera. Since I want to create a virtual window of my desktop screen into the virtual reality, I'm just entering here the size of my screen, which is 0.38 meters in width and 0.22 meters in height. And I have to change the main axis of the orientation plane to the y-axis. So it's actually turning into the right direction I want to have it. Now I can start turning rotation, change rotation. The look at transformation node. We can see now, no matter how the camera is looking at, it's always pointing at the gaze point. That's what we actually want to have. So I'm kind of trying to get the angle of the screen I'm sitting in front of, creating a new node, shape node, select the plane, tell it to be transformed at the lookat transformation, and I draw it into the first draw group and tell the 3D viewer to show that one as well. I'm going to scale the whole lookat transform nodes, and then in here inside of the shape nodes I'm going to do the same thing as I did before. I'm setting the width and the height of the shape node. I'm going to rename the shape mode to screen. And now I'm going to create a capture node. The capture node is actually capturing 3D space, and tell it to be hooked up to the lookat camera, so it's going to capturing what the lookat camera is looking at. I'm going to change the recording dimensions so my humble machine is not going totally crazy, and I'm telling it to capture the second render group. I'm linking the output of the scene capture to the screen, and now actually the screen shows the texture, the result of the screen capture, which is still black simply because there is nothing to be captured, but we're going to change that now. I'm going to create a new grid and pin the property window, select a different transformation parent. Now I make a local transformation, turn it in at 90 degrees, and resize again 0.38 in the width, and the height should be 1. I'll leave it to 1, and I drag it a bit to the back and up. So that looks cool. I'm changing the render group, so actually the scene capture can capture it as well, but the angle is still not correct. So if I'm turning the angle, I can see now the render result is being shown on the screen object as well. Duplicate the grid and repeat the whole process. The only difference is that this grid is actually on the lower rim of the screen. And now I'm going to create a window, enable it, and tell it to render it out to the display. So when I press the desktop, it's actually showing it here. Now I also need a viewport. Tell the viewport to be rendered to the window just created, and hook up the capture node to the window. And now we can see down in the output window, adjusting the angles of the desktop until actually I'm sitting now straight in front of my screen, looking at it straight into the screen. I'm adjusting it now, and now if I start moving around my head, you will see that these movements are reflected by everything else. So actually it seems for me, from my point of view, as if I'm looking into a space defined by those grids. I'm moving those output windows so we can actually see the viewports of the HeadRoom application in the background. So you can see now if I move my head, everything is interacting accordingly. That's basically the most basic setup I can imagine for using HeadRoom. Now you obviously want to add some more content. I'm going to do that with one of my favorite nodes, which is the ray margin node. Just add under effects, ray marger. Now since we saved a project inside the tutorial, I have access to all the ray margin shaders that come with these tutorials. And create another shape object. I keep it a sphere. I want to render it into the same group that the scene capture is capturing it, but I make it a very big sphere, so it's actually around everything, and I apply the shader to it. Now all I have to do is I have to rotate inside the property of the shader to -90 degrees, and now we can see we have here the nice wave scene all around us. Now as you can see, the shape actually is drawing to the second render group, while the scene capture is capturing the second render group, but we don't see any output there yet. The reason is that the look-at camera's far frustum is too short. We have to resize it. Now it's actually catching up, and now we actually have what I intended. I created a little virtual window into a virtual room, and from here you can go further, choose a different shader, or create classic OpenGL setup. So that's it. Thanks for watching, and I hope you can get started with this info.